Good evening. This is the last lesson in Chapter 9, and it's all about rotations. In tonight's lesson, we're going to be able to graph rotations, and you're also going to be able to identify rotational symmetry. So we're going to go ahead and get started. All right. So when we talk about rotation, that's the last type of transformation that we're going to talk about. And this is one that actually turns the figure on a fixed point. So here, I have two triangles, and they're rotated on the point P. All right, and that is considered the center of rotation. So P is a fixed point or center of rotation in this one. The angle of rotation is what is the measurement of how we're rotating it? And many times you're going to see based on 90. So 90, 180, 270 degrees, or all the way back to 360 or 0 degrees where it started. Now in this textbook, so when you do your assignments, you're going to notice that all the rotations are going to go counterclockwise. So you're never going to actually rotate it like the clock, so going to the right. It's always going to be to the left. Now I'm going to tell you straight up, this first part of the lesson is kind of hard to show you on my smartboard. All right, I'm going to try to talk you through it, and hopefully in class tomorrow I can show you a little bit more if you're confused about what I mean. So it says find the vertices of the image of triangle RST after a rotation of 90 degrees about the origin. Then show what a rotation of 180 degrees will look like. So when you do these, they're going to give you something like this graph. They're going to have a shape, and they're going to have these different vertices or side points. So points RS and T are our vertices. Now how you do this is very simple. What you need is just a piece of like tracing paper or some line paper or online paper. And what you end up doing is you place that piece of paper, and again, I know you can't see me doing this, so I'm explaining it to you. You place that sheet of paper over the graph that they give here. And what you end up doing is exactly what it says in number 2. Trace the figure. So you trace exactly the figure they give you, the x-axis and the y-axis. So when you trace the figure, make sure you put R, S, and T around it too. There you go. So I just did that, and you're going to see me do the next piece here. It says rotate the paper number 3. Well, if we rotate counterclockwise 90 degrees, 90 degrees is going to be in the next quadrant. 180 will be in the one after it, and 270 degrees will be in the third one. So if I were to rotate this, that means actually turn your paper counterclockwise 90 degrees. And then what ends up happening is where those points are, and I know you see some things come up here. Oops. Are they going to let me write on it? All right. There we go. I end up with R is right there. S is right there. And then again, holding up my paper, T is right there. And again, that is after the first rotation. So that's after 90 degrees. So what you do again is flip your paper one more time to get to 180 degrees. And that'll show you where they are here. And you copy those lines. So here, this is R after it's rotated twice. Let's see. And again, I line up the X and Y axis. That's how I know. S is after that one. And then finally, T is right here. This is a second rotation. So after 90 degrees, your triangle actually looks like that. After 180 degree rotation, it actually looks like that. And again, you do the same idea if you were going to 270. You would just turn your paper counterclockwise 90 more degrees, and that'll give it to you one more time. And then to 360, you rotate once more, and it'd actually be the exact same one you had before. So I'm not going to spend a lot of time on this one since you couldn't actually see me doing it. So again, tomorrow in class, if you have questions, I'll be happy to show you more about it. So now we're going to the second piece of the lesson, which is on rotational symmetry. We've talked about symmetry before. That's when it looks the exact same mirror image on both sides. Now, a figure has rotational symmetry if a figure would match the original if it's rotated 180 degrees or less. So if you turn it halfway around and it looks the same, then it's actually rotational symmetry. No, they'll ask you to figure out what is the figure's rotational symmetry. So for example, if you have a figure and you can turn it 5 times and it looks the same, well then you take that 360 degrees by that number of turns where it looks the same, and that'll give you the rotational symmetry. So this is an important part of the second part of the lesson. So here we go. Judging from the appearance, tell whether the star has rotational symmetry, and if so, what is its angle of rotation? So what I did here was I actually put a green dot at the top of it. And now what I'm going to do is I can go ahead and check to see, well, if I rotated it, when will it look the same? Well, right away, oh, would you look at that? It already looks the same. So I know it does have rotational symmetry. Now I just have to decide how many times would it be rotational. So I'm going to start at the beginning. Well, here's 1. If I flip it, well, there's 2. 3. 4. It looks the exact same. 5 times now. 6 times. And I'm back to the beginning. Woo! Getting a little crazy. So there are 6 times that it has rotational symmetry. So I take 360 degrees, divide it by the number of times, and I get 60 degrees. So the rotational, or the angle of rotation here is 60 degrees. Every 60 degrees I turn my figure, I have rotational symmetry. So again, I can do the same with this one. Judge if this hexagon has rotational symmetry. And again, one of the things I can do, I can outline or trace the top of it, so I know. And here I have to actually group it so I can see it. There we go. So that line will stay there now. So I can flip it now. Well, here, no, that doesn't look the same. Ah, but there it does. And it does not there again. So yes, it does have rotational symmetry. And, well, there were 2 times that it happened. So, here and when you were there. So 360 divided by 2 is 180 degrees. So the rotational symmetry on this one is 180 degrees. Then you look at this angle, or this arrow, I should say, and yeah, we know that it has that line of symmetry. But if I were to try to rotate it, is there any other time it looks the exact same? And looking at it, nope, 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 nope. I go all the way back to the beginning. So is there any rotational symmetry here? That would be no. There we go. And that is your lesson for tonight. You have a fantastic night. I will see you in class tomorrow. Adios.